Okay, LeetCode problem 2095, delete the middle node of a linked list. So you're given the head of a linked list, and to delete the middle node, we need to take the middle node here, connect its previous pointer to its next pointer. So if you've got a odd list like this, it's easy to find the middle one using a slow and fast pointer, but if you have an even list, that slow and fast pointer will automatically take the next one. So if you have four nodes, if you have 1, 2, 3, 4, it will delete the third one, which is what the algorithm is asking for, and it just does that by default. So you don't have to worry about that. So to start the problem off, we got to make sure the head.next exists. So you have more than one node. And if you don't, head equals null, because we're deleting the only one that is left. And then just return head. Else, okay, we'll set a slow pointer to head and a fast pointer to head. And while we have a fast pointer and a fast.next pointer, so at some point fast.next would be null, which that means we've reached the end of our list. So for each iteration, I need to add a so previous is set to null, and we're going to have a previous counter that is equal to slow at first, but through each iteration, previous will be right before our slow pointer, so we have something to connect it to our next pointer after the current pointer. So each iteration, I will prev equals slow, and then slow equals slow dot next to increment it by 1, and then fast equals fast dot next dot next. So fast is kind of our cutoff point, because when fast.next.next equals nothing, when there's nothing, it'll end. And therefore our slow pointer will be in the middle because it's moving it in by 2, or half as fast as our fast pointer. So we have our middle, and then from there, because it's a singly linked list, all you have to do is connect that previous pointer to that next pointer and skip over our current pointer, which is slow, which would be the middle node. So prev.next equals slow.next. And then we just return it. So let's see if that works. And it does.